Hello everyone and welcome back to the channel. In our previous discussions, we have explored HTTP as a fundamental protocol for web communication. But HTTP, with its request response model, has a significant limitation when it comes to truly real-time applications. How do you get instantaneous updates from a server to a client without constant polling? This is where WebSockets come into play. In system design interviews, discussing WebSockets effectively showcase your understanding of real-time communication pattern. Today, we are diving into the magic of WebSockets. So let's first understand the problem WebSockets solve. Standard HTTP is unidirectional and stateless. The client sends request and the server sends a response. If the server has a new data, it can't just push it to the client. The client has to ask it. There is two ways to solve this problem with using HTTP. We can use polling. So if we have the client here and we have the server here, we can use what we call polling. Basically, the client will repeatedly send GET requests to the server at fixed intervals. Like, for example, the client will send requests every 5 seconds, for example, to check for updates. This is highly inefficient, and it introduces significant latency because we're waiting 5 seconds for each requests, and waste network bandwidth and also server resources because we send a lot of requests and maybe most of them or some of them might have no new data. It basically goes like that. The client, let me delete this to be easier for you guys to see. The client will send a request to the server asking the server, do we have anything new? The server will say, no, we don't have. The client every another 5 seconds will send, do we have anything new? The server will say no. The client will send a third time after 5 seconds. Do we have anything new? The server will say yes, we have something new, and it will send it back. So we made like 3 requests to just get one piece of data. So this is not efficient at all. There is a better solution for it, but it's not also a perfect solution. It's not as good as WebSockets, but it's better than polling, which is long polling. The client sends a request, okay, and the server holds the connection open until it has a new data or timeouts occur. Once data is sent, the connection closes and the client immediately opens a new one. This is better than basic polling, but still involves connection overhead and isn't truly fully duplex. These methods are clunky and resource intensive for applications demanding true real-time updates like live chat or stock tickers. So when the client tries to ask the server, do we have anything new? The server will hold this request, let's say that for 5 seconds. If it got anything new in these 5 seconds, it will send back the data to the client. If it didn't get anything new in the 5 seconds, it will send a request, an empty request anyway to the client. So it's better than polling, but still not the best solution. Okay, so this is where WebSockets revolutionize real-time communication. Sorry, my English is not that good. So a WebSocket is a communication protocol that provides a full duplex persistent bidirectional communication over a single TCP connection. What means a full duplex and persistent? Okay, so in simpler terms, it's a bidirectional communication. The server can send requests, or maybe can send any request, and the client can send requests, and the server can send responses without the client asking for it. That means it's full duplex. Full duplex, this means data flow simultaneously in both directions, from client to server and from server to client, without waiting for a request response cycle. and it's persistent. Like once it's established, once this connection is established, the connection remains open for a long duration, eliminating the overhead of repeated HTTP handshakes. Think of it like a phone call versus sending letters. With HTTP, you can send a letter and wait for a reply. With WebSockets, you establish a continuous phone call where both parties can speak and listen to each other in the same time, so simultaneously. Okay. Let's understand this. And I would say this is quite big. You need to focus on this section. It's not that easy, but you need to focus on this section because you've been asked about this section in your system design interviews. So how does it work? First, there is something we call HTTP handshakes. So we have the client here and we have the server. The client will initiate the process by sending a regular HTTP by sending a regular HTTP request to the server. However, this request includes specific headers. Most notably, it's something called it will be upgrade, and the header upgrade, and it equals WebSockets. I don't know if I did write it right or not. And also there is something called the connection equals upgrade. This signals to the server that the client wants to upgrade the connection to be a WebSocket. Okay, so this is the first thing in the handshake. The server will respond. If the server supports WebSockets, it responds with HTTP 101 switching protocol status code and confirms the upgrade WebSockets header. And after that, the persistent TCP connection, like at this point, the initial HTTP connection is no longer an HTTP connection. It is upgraded to a long-lived dedicated WebSocket connection over the same underlying TCP channel. And after that, once the handshake is completed, data frames can flow now freely and simultaneously in both directions over this single persistent, and it has a persistent connection. There are no HTTP headers sent with each subsequent message, leading to much lower overhead. This initial HTTP handshakes makes WebSockets compatible with existing web infrastructure like firewalls and proxies, while providing the efficiency of dedicated TCP connection for subsequent messages. Okay, so right now we understand what it is and how it works. We need to understand now why WebSocket matters in system design. WebSockets are indispensable for certain types of applications, but they also bring but they also bring their own set of one minute. I guess I missed my script. Yeah, okay. So again, why WebSocket matter that much? WebSockets matters, or maybe in real-time applications, because they are essential for any application requiring instantaneous updates, like live chat messaging, live sports update, online gaming, collaborative editing, like Google Docs or something like that, and real-time dashboards, notifications, anything for alerts. Also, it reduces latency because updates are pushed immediately from server to the client, eliminating polling delays. Number 3, it reduces network overhead because after initial handshake, message frames are tiny compared to a fully HTTP request, saving bandwidth. And lastly, efficiency, less resource intensive than continuous polling for both client and server. We will talk about some challenges with WebSockets. The first thing, we have the stateful connection. Unlike stateless HTTP, WebSockets maintain a persistent open connection between a specific client and a specific server instance. This makes horizontal scaling quite harder, as subsequent requests from a client need to hit the same server instance, often requiring a sticky session and the load at the load balancer level. Yeah. And number two, connection management. Like a single server can only handle like not that much number of open connections. Building system for millions of concurrent WebSockets connection often requires a specialized WebSocket servers or gateways separate from your main application logic. Number three, message broadcasting. Here, how do you effectively send message? Basically, like new message in the chat room X, for example. Like how you would how do you efficiently send messages to thousands of clients connected to different servers instances? This typically requires a publish subscriber messaging system like Redis pops up or Kafka to coordinate messages across your WebSocket server cluster, and it's not that easy to deal with. Okay, how will you use WebSockets in your system design interviews? So when you discuss WebSockets in an interview, you need to bring them up when real-time features like live chat, notifications, collaborative apps, or gaming are mentioned. Okay? Always construct them with traditional polling to show your understanding why WebSockets are better. Also, crucially discuss the scaling challenges, like mention the stateful nature and need for sticky session or dedicated WebSocket services, and how you would handle broadcasting messaging using a PubSub system. Also show an awareness of technologies like Nginx for proxying WebSockets or specific WebSocket libraries frameworks. So yeah, that's it for this video, and see you in the future.